Okay, this is a quiz. Now the test 2 was randomly generated, so my test 2 questions might be the same as yours or slightly different, but you should be able to get what happened, be able to get the answers to yours out. So let's have a look at this. The first says, here's the graph of G, and identify the graph of Gx plus 3. Well, we have to know when you add 3 to the end of the equation, that means shifting it 3 units up. And if I shift this point 3 units up, then it's still going to have the same x coordinate, but the new y coordinate is going to be 2 plus 3, which is 5. So I need to find a drawing that is shifted 3 units up, this picture, and the point is -3, 5. And we can see that that first example there is the one that is showing us. Okay, so none of the others give that. And so that's the answer to that one. Let's go to the second question. It says, given the function of g, identify the graph of g evaluated at x plus 3. So when x is replaced with x plus 3 inside the parentheses, that's going to be shifting this unit 3 units left. So picture this graph shifted 3 units left. Where will this point be? It will be 1, 2, 3 units to the left. So the new graph should show us a point with the coordinates. Well, -3 minus 3 should be -6, and the y coordinate will be unchanged. So I'm going to get -6, 2 in my picture, and then the graph shifted 3. That's what I'm looking for in my picture. So again, it was knowing your chart of transformations. And here's the one with the point that I need. Okay. Okay. And now let's look at the graph of this one. Okay. And so we have to remember what our transformations were, again, from the list. So how would I do this? Okay, so if I have negative f of x, that takes the graph of f and reflects it in the x-axis. And if I start with the graph of f, and I have f evaluated at -x, that's a y reflection. Okay, so this is my graph. Now, if I was going to reflect this in the y coordinate, so if I had this, then if the y-axis is a mirror, this part gazing in the mirror would look something like that. And this part over here gazing in the mirror would look something like that. And so that's what this graph should look like if that's my reflection. And that's not what's happening here at all. So it's not going to be that. Okay. So let's see what happens if I take this and reflect it in the x-axis. Okay, so the x-axis, if it's a pond or a mirror, this portion up here, its reflection would look something like that. This point down here would be reflected up here, so this reflection is going to look something like that. And this portion reflected in the x-axis will be this down here. And this portion reflected in the x-axis is going to be this part here. And this portion reflected in the x-axis is going to look something like that. And sure enough, that is what we're seeing here. And so if the black is the graph of f of x, then what we get is a y reflection, and that's going to be this selection here. Okay. Identify the graph of h evaluated at 3x. Okay. So if I had the 3 out the front, then an old point, or a point that's identified, becomes a new point, and the new point is gotten by multiplying the y coordinate by 3. That's not the case here, but I think in the randomly generated bank, that's one of the questions. If we're asked to find that, then from our chart of translations, what that does is you get a new x coordinate, and the new x coordinate is going to be the old x coordinate times 1/3, and the y coordinate will stay the same. Okay, so this is the one for this question, so we're not concerned with that. I think one of the other test banks did have that question. So now here's the graph. The point that's been given me, one of the points that's been given me is 3, 3. And under this translation, it's going to be carried to a new point. It'll be 1/3 times the old x, and the y coordinate is unchanged. Oh, sorry, the y coordinate is unchanged. And so my new point is going to be 1, 3. So, and then the other point I was given was this one. And the new point I'm going to be given is that divided by 3, which is -1. And this one stays the same. So I'm looking for these 2 points to be on my selection. So 1, 3 and -1, -3. And so we can see that that's what we have here. And so this is going to be the graph that we want. None of the other graphs have those points on them. Okay. All right, and so what does this one ask? What is the graph of f of -x plus 3? Okay, well, we had to know our translation list, and so that's going to be a reflection in the y-axis. So we're going to reflect in y. And then this means we're going to take it, shift it up 3 units. Okay, so I'm going to start by reflecting it in y. Oh, sorry. So reflecting it in y. This part will be reflected. Let me do a different color. No, trying to get. This part will be reflected here, and that part would be reflected there, and this part reflected in the y-axis is going to be that. Okay, so that's that first step. Then take the green one and have it up by 3. And so that's going to push it right up to the top here. Okay, so this is the one that I'm looking for, what I've drawn there in red. Okay, so the only one that does that, that's a y reflection, then it was shifted up. And there's no scale here, so that's the only one that it can be. So I wasn't sure how much 3 was, I just knew it would be above. So that's the one I'm going to answer. Okay, so this says, given the graph of f of x in blue, that's the graph of f. which is the graph of 1/3 of f of x. So if we start with f of x in blue, then if I want 1/3 times f of x, what that does is it keeps the same x coordinate, but the y coordinate is changed to 1/3 times y. Okay, so here I've got the point 0, 1.5, and its reflection would be 0, 1.5 divided by 3, which is about there. Here I've got the point, looks like, well, the y coordinate is 3, and the new point, well, the x coordinate will not change, but the y coordinate will be 1/3 times 3, which is down here. So it's going to be this one. Okay, and so this one is labeled B. Okay, so that's the graph that we want. We want the graph of B. All right, identify the type of equation. Okay, so let's see what happens when I try and solve it. Let's add x to both sides. So when I do that, then on the left-hand side, I'm going to have 2x plus 2. And over here, that's going away. I'm going to have 5 minus 3, which is equal to 2. Now I will subtract 2 from both sides. And so that's going to give me 2x is equal to 0. And then I can solve this for x by dividing both sides by 2. And so x is equal to 0. I have one answer for my solution here. So if you have an identity, then there are infinitely many values for x. So it's not an identity. If you have a contradiction, you get a statement that's not true. And so what we have found here is a conditional. This is the condition. X has to be equal 0 to solve this equation. All right. And so it was also mentioned in the lab, if you get one answer, you have a conditional. If you get infinitely many answers, you have an identity. And if you get a false statement, you have a contradiction. Let's see what we have here. What am I going to do here first? I'm going to subtract x from both sides. So when I do that, then this cancels out, and that cancels out, and I'm left with 2 on the left-hand side is equal to 6 minus 3. That is a false statement. And so what we have here is a contradiction. You have a contradiction when you have a false statement. Okay. Question 9, find the slope of the line containing these 2 points. Okay, so the slope is equal to the change in y over the change in x. So it's going to be this y coordinate minus that y coordinate divided by this x coordinate minus the first x coordinate. So I'm going to get negative 2. And then I'm going to have negative 5 plus 5. And that will give me 0. And that's not defined. And so the kind of line that contains those 2 points is a vertical line, because its slope is undefined. Find the slope and the y-intercept of this line. Well, we need to rewrite it. Okay, so I'm going to need to subtract 5x from both sides. So when I do that, I get 9y is equal to negative 5x plus 38. because I want it in the form of y equals mx plus b. That's why I put that term first. Now I need to get y by itself, so the next thing I have to do is to divide everything by 9. So this is now in slope-intercept form. And so this is my slope, and this is my y-intercept. So the y-intercept is 0,38 ninths. So this is wrong, and that's wrong, so we can rule those out. And my slope is negative 5 ninths. Okay, so the only one that's going to see this has the wrong slope. So rules that one out. So my answer is going to be that third one. Okay, we want to find the slope of the line. Well, before we were spoon-fed 2 points. Here you can clearly see 2 points that are marked on this graph. So on this graph, that is the point 3, 0. And this is the point 0, -3. Okay, so I can find the slope now. It's going to be change in y over change in x. So this one minus the y coordinate of that one divided by the x coordinate of this one minus the x coordinate of that one. So in the numerator I get -3, in the denominator I get -3, and those reduce down to +1. The negative signs cancel and 3 over 3 is 1. So I want to choose the answer 1. Okay. Graph the line containing the point and having slope m. Okay, m is 0. If m is 0, if the slope is 0, that's telling me we have a horizontal line. And that might be enough to make a judgment. Okay. Okay, so no, I have 2 horizontal lines, but I see it's not going to be that one because that's not a horizontal line. It's not going to be this one because that's not a horizontal line. So we have a horizontal line because the slope is 0. And let me scroll. And it contains this point. Okay. So if it's a horizontal line, it has the equation y equals a number. And the number is going to be the y coordinate of this point. So what does y equal 1 look like? Well, if that's where 1 is, then the line y equals 1 is the horizontal line that goes through that. Okay. And now we should be able to see it's not going to be that. That looks like the horizontal line y equals -1. That's going to be the one we want. Okay. Up. There. Okay. All right. Let's go to this one. Find the slope and the y-intercept of the line. Okay. So again, we have to get it into that slope-intercept form. So I'm going to subtract 4x from both sides. And so I'm going to be left with -5y on the left-hand side. And I'm going to subtract 4x, but I'm not going to write 5 minus 4x. I need to put the x term first. Okay. Now I have to get y by itself. So I'm going to divide everything by -5. Okay, so these will cancel, and I'll be left with y equals, the negative signs cancel. So I have 4/5 times x, and then after cancellation there I'll have -1. So my slope is 4/5, because now it's in the form where I can read it off, and my y-intercept is going to be the point 0, comma, -1. So these have the wrong intercept, so it's not those. And my slope is 4/5, so it matches that one. Okay. Find an equation for the line with the given properties. Okay, perpendicular to the line x equals 3. What kind of line is x equals 3? It's a vertical line. Oops, let me do that in black first. It's a vertical line. And if that's where 3 is, then the line x equals 3 is the vertical line that goes through 3. Okay. So that's that line. Now, we've been asked to get the line that's perpendicular to x equals 3. A line perpendicular to a vertical line is a horizontal line. So what we want is the horizontal line that contains 1, 9. Now, a horizontal line has equation y equals a number, and that number is going to be the y coordinate of that point. And so where would that be? Up here. And the line y equals 9 looks like that. And we can see that these are perpendicular to each other. But it wants the equation of the line, and it is y equals 9. Okay. Find an equation for the line with the given properties. A vertical line. If it's a vertical line, then its formula is x equals a number. What's the number? Well, if that's a point on the line, then you have the x coordinate of that point. And so that's what we want. So question 15 is, answer to 15 is A. Or the first one, sorry. Decide whether the pair of lines is parallel, perpendicular, or neither. Parallel lines have the same slope. Perpendicular lines have opposite flips and negative sign of their slopes, or neither. Okay, so we have to get the slope of these. There's no other choice. Okay, so the slope for that line is going to be 7 minus 5 all over -4 minus -20. So I'm going to get 2 in the numerator, and I'm going to get -4 plus 20, 16 in the denominator, which reduces to 1/8. That's the slope of that first line. Now we want the second line. We want the slope through that one. So the slope is going to be the difference in the y values, 4 minus 5, divided by the difference in the x values, 7 minus that x value. So I'm going to get -1 in the numerator, and I'm going to get 7 plus 5 in the denominator. Okay, and that won't reduce anymore. Now, these lines are not parallel because the slopes are not the same. If they were perpendicular, well, what's perpendicular to this one, and that's the symbol for perpendicular, would be the flip and then take a negative sign. So a line with slope -8 would be perpendicular to that. What would be parallel to this one? Well, a line with the same slope. What would be perpendicular to that one? Well, flip it and then take the negative of it. So a line with positive slope 12 would be perpendicular to that. These are not related in any way, so the answer is neither. Find an equation of the line satisfying the conditions right in slope-intercept form. Okay. Now the key word here is parallel. So we have to get the slope of this line. It's not in any condition that we can see the slope, so we have to rewrite it. Subtract 3x from both sides, and you'll get 7y equals, and you have to write the x term first, negative 3x plus 3. Then you have to divide everything by 7. And so we're going to have y equals negative 3/7 times x plus 3/7. So the slope of this line is negative 3/7. And if it's parallel, it will have the same slope. So I can look at this one, and that has slope negative 7/3. It's not the same. It's wrong. I can look at this one, and it has slope positive 3/7. That's not going to be the same. It has to have slope negative 3/7. So just by that alone, this is the only one it can be. This has the same slope. So I didn't even need to test that. Okay. Find an equation parallel to that line containing this point. Okay, let's see what we can do. Parallel, again, it has to have the same slope, but it's got to be in slope-intercept form before I can use it. So I'm going to take this and I'm going to subtract 8x from both sides. And then I'm going to divide everything by 7. So if it's parallel, then it has to have the same slope. That is the slope, and if it's parallel, they must have the same slope. So, okay, so if I'm going to do that, I'm going to have to get the slope of these. Okay. And containing the point 70. Okay, this contains the point 70. If x is 7 and y is 0, and you plug it into here, you'll get 8 times 7 minus 0 is 56. 70 is not on this line. X times 7 is 49 plus 8 times 0. So 49 does not equal 0. I can rule that one out. X times 7 is 49 plus 7 times 0 is not 98. Okay. And x times 7 is 8 times 7 is 56 plus 7 times y, 7 times 0. Okay, so I've reduced it to these two, which is good. So with that first one, does that have slope negative 8/7? Well, I need to subtract, so I'm looking at this one. I need to subtract 8x from both sides. And then I need to divide everything by negative 7. And when the negative sign's clear, that's going to give me 8/7, positive 8/7. And that's not the same slope. I can rule that one out. And so by process of elimination, it's got to be that one. Okay. All right, we're almost done. Find an equation for the line with the given properties. Perpendicular to the line y equals negative 4. What kind of line is the line y equals negative 4? If it's y equals, then it's a horizontal line. So this is the line. Okay. Now, what kind of slope do horizontal lines have? They have slope of 0. Okay. But we want a line that's perpendicular to this red line. Perpendicular to the red line is going to be a vertical line. So vertical lines and horizontal lines are perpendicular to each other. So I want a vertical line that contains this point. A vertical line has the equation x equals what? Well, the x coordinate of that point. And so this is going to be the line we want. So it goes through 2. 2 is there. All right, so x equals 2 is the line that we want. Okay, if you saw this perpendicular to that line, that's a horizontal line. Perpendicular to it is a vertical line. So you could have immediately said that's not a vertical line, and that's not a vertical line. It's going to be one of those, and it's always x equals the x coordinate of the point. All right, so that's my answer for that one. Okay, and finally, get down to the last two. Find an equation for the line in the indicated form with the given properties. Okay, so general form is like standard form. So let's see what we have here. First, we have to get the slope. If you have 2 points, you can always get the slope. So the slope is going to be that y coordinate minus that y coordinate all over the change in x, which is that x coordinate minus that x coordinate. This will be 3 plus 7, which is 10, all over negative 4 minus 5, which is negative 9. So my slope is negative 10/9. So I'm going to have to use the point slope version. Okay, so you can choose a point. It does not matter which one you choose. Okay, so I might choose this one. So this is going to be x1 and y1. So this becomes y minus y1 is equal to the slope, which is negative 10/9, times x minus x1 minus negative 4. So I'm going to have y minus 3 equals negative 10/9 times x plus 4. All right, so how about we multiply everything by 9? If I multiply every single term by 9, I'm going to get 9y minus 27 equals, and then if I multiply the 9 by this fraction, I get negative 10 out the front. Okay, so it might make this calculation easier. So I'm going to have 9y minus 27 equals minus 10x minus 40. Okay. Now, when you're looking at the forms here, the x's are out in the front, so I'm going to add 10x to both sides. So if I add 10x to both sides, that goes away. And then I'm going to add 27 to both sides. And do that, it's going to be the negative of that. 10 minus 7 is 3. 3 minus 1 is 3 minus 2 is 1, and this will be negative 13. Okay, this is what I want. 10x plus 9y equals negative 13. So question 20 is going to be that one. And then finally, the last question, find an equation for this line containing the points and the general form. Okay, same thing. So the slope is going to be this y coordinate minus 7 minus 0 all over 5 minus negative 4, which is 5 plus 4, which is 9. And this is going to be the point I picked because it has a 0 in there. So I have y minus 0 is equal to 7/9 times x minus negative 4, which is x plus 4. So multiply everything by 9. Okay, so multiplying that by 9 knocks it out. Then I have 9y is equal to 7x plus 28. And if I subtract 7x from both sides, I get that. And now I want my leading term to be positive. So now I'm going to multiply everything by negative 1. Okay. And so I'm going to get, that will become 7x, that will become minus 9y, and that will become minus 28. Okay, and that is matching with that one. Okay, and so I'm going to end this.